Okay, so hey everyone. So today we're going to solve LeetCode 149 max points on a line. It's a hard problem, although I will not agree that it is that hard because there are some LeetCode hard problems that are genuinely way harder than this problem. But anyways, it has a lot of concepts. It has a lot of what do we say, like out of the coding requirement. For example, you need to understand the geometry concepts like line equation and the slope concept. So yeah, for someone who is not from a math background, or although that math, the level of that mathematics is nothing more than just ninth or 10th class maths, but still, I think it could be a challenge. You may have to revise some concepts for this problem. But anyways, let's start this problem. So we are given an array of points where points of I is equal to xi and y. This is the x coordinate, this is the y coordinate of a point. We need to represent that are represented on a xy plane. So this is the xy plane, this is x and this is y axis. Return the maximum number of points that lie on the same straight line. Okay, so the question says that we are given some points and we need to connect these points, or look for a straight line after connecting all the points together. And what are the maximum points that are we can observe on a straight line? So for example, let's take this example. Yeah. So okay, so we have this problem, and so this is the graph, right, that is given to us. This is one point, that is 1 comma 1, 1 comma 1. Then you have 3 comma 2, that is this one. And then you have 5 comma 3, this point. Then you have 4 comma 1, this one. Then you have 2 comma 3, 2 comma 3, this one. And you have 1 comma 4, that is this point. Now after having these points, you can connect all of them together if you want to, because will also be a straight line going somewhere in this direction. Yeah, so after having this straight line, these are two straight lines. You can also have a straight line like this one as well, and you can also have a straight line in this direction. Then you can also have straight line in this direction, this one and this one, right? So now all of the points are connected to each other. Like for example, this point is now connected to all other points, and this point is connected to all other points as well. So if you will look closely, and you also have this line, the dotted line, I'm not overdrawing it, all of the straight lines. So for example, this straight line, this has 2 points on it. This also has 2 points, 2 points, 2 points. This also has 2 points on it. Okay, this is interesting. This line, it has 3 points on it. This also has 2 points, and this line also has 2 points. But the dotted one, this line has 4 points on it, and you need to return maximum points that can be attained on a straight line. And our answer will be 4. This is the answer. How we can do this? So if you are aware of the slope and straight line concepts, then you can solve this question very easily. So what we can do is, like for example, I'm talking about the first method that comes to my mind, although that method is not correct because of some limitations. Because some of, I will not say, yeah, more like a limitation, or some of the concepts that are not matching enough in the programming and mathematical world. So for example, you can, for every point, right, you can ask for a line. So for example, I say that, this point has a line connected to this one, has a line connected to this one. This is L1 and this is L2. Now the equation for L1 will be, if I want to check if what is the equation for L1. So line is equal to, basically the line equation is, L1 equation will be, um, y is equal to mx plus c. And let's say this is the point, right? This is the point, and we don't know what is y. So let's say we are taking y2, right? This is x2, y2, and this is x1, y1, and this is x3, y3. Or you know what, let's take it more in a more sophisticated way. This should be x2, y2, and this should be x3, y3. Fine. And this is simple x1. This is not, so not x1 actually, this is simple xy. Now when you are checking the line equation for L1, right, for the line L1, so y is equal to y3, not actually y3, this should be y1. What am I doing, man? Y1, yes. Okay, finally. So now we have this equation. With the help of this equation, let's create an equation for L1. So L1 will be y1 is equal to m of x1 plus c. Now I can calculate m, right? So the slope, m is basically the slope, and the slope formula is y2 minus y1 upon x2 minus x1, right? And with the condition that x2 minus x1 should not be equal to 0. Otherwise this whole thing will be undefined. We don't want that. So slope for this line will be, so for example this line slope will be y1 minus y, x1 minus x. This is the slope. So equation becomes something like this: y1 minus y minus x multiplied by x1 plus of c. Now after having these values, you know y1, you know y, and you know x1. After having these values, you can calculate the intercept. You will have a value of intercept. So by having this value of intercept, you will know what is the m. So with the help of these values, you will know what is the value of m and c, the value of slope and an intercept. So you can say that if this line, if this x1 and y1, if this xy and x1 y1 creates a line with this m and c, and let's say there is another point, let's say here, so this point lies on that straight line, right? So if I want to calculate this line, that is L3, this will also have the same values, m and c. The slope will be same because it's lying on the same part, and the tangent will obviously be equal because that point is residing on the line, and the c value will also be same because it's on the same line. So this is one way of solving it. With every point you can calculate which line do they correspond to. If they are from L1, okay, if x, so let's say we have a point here p and q, right? So if x and y, so xy and x1 y1, they are forming a line which has m value of m and c, which has a value of slope and a c, right? Let it be m and c. xy is also forming a line with p and q, which is also having the same value of m and c. By this observation I can say that x, by this observation I can say that x, pq and x1 y1, they are lying on the same line. If they are lying on the same line, then the number of points on this line is 3. Similarly, I can calculate for this line and my answer will be 4, and this is one way of solving it. But what is the limitation that I was talking about? The limitation is, in this case, so let's say we have a point, let's say 0, 1 and 0, 0, right? Let it be 1, 0. Yeah, 0, 1, right? Now in this case, the m value. So what is the slope value? Slope value is going to be 0, y minus 1, 0 minus 1 upon 0 minus 0. In this case, this is going to give me a problem. This is basically not a number in C++, and this can also, I think, create some runtime errors in other languages, because I remember in Java it used to be something called or maybe an exception, runtime exception error, I don't know. But this is a fault, right? Because if you will take this into consideration, that if x and y, if x1 is equal to x2, then we can have this condition to be overlooked. But this is also a problem. Why? Because then you will be giving an m a default value that is an infinity, or let's say minus infinity or something, right? You will be giving some value. But you know what, if m is infinity is or minus infinity, let's say we have two lines, L1 who has a m value as infinity, and we have L2 who has a m value as infinity. You know what, you will say that these are same line. These are not same lines. Their intercept could be different. It could be minutely different, but yeah, they are different. So this is the point that I want to highlight, that with using an intercept concept, this would be a problem. Then how to solve it in a more resilient way that we don't have to worry about the intercept and all of that. So let's see how we can do this. But before, let me clean this up. Okay. So now let's try another approach. Another approach is that at every point, I will try to draw a line to all other points. I will say that let's draw a line to this one. It has a value of m. I'm not dealing with c because c was giving me problem earlier, right? That is the whole concept of this method, that method 1 was giving me a problem when I'm dealing with intercepts. So I will be ignoring it. I'll be choosing that approach which doesn't require the need of a intercept. At this point, I'm making an m. Okay. At this point, it will be different. So let it be m1. This will be m2. And when, so this is my main point where I'm concentrating, right? And yeah, this should be like this. So this is m2 and this is m3. Fine. Okay, now I create this type of, and now I'm marking their, let's say, their slopes with every point. With this point, I'm trying to connect every dot with this point, every point with this point, and checking what is the slope of that line, of the resultant line. Now I go on and connect this one, right? So first I connected this one. Now I'm connecting this point. At this point, I realize that the slope is equal to m2. So I will say that this is m2 as well. Okay, but if it is equal to m2, then it means that this point and this point and this point, they all are lying on the same line. I will note at this point that this is lying on the same line. And then I go to this point, create a line right from this point, and I have created another line to this part. And at this point, I will say that the slope is again m2, which means we will have 4 points on this line. Fine. So we will record that we have 4 points. Now my concentration will be changed, and now I'll be calculating this for this point, right? This point. And at this point I will say let's connect it to, well, I will not be previously connected with this point because this doesn't make any sense. I have already processed it by connecting in this direction because it's a line. It's not like we can just have it like xy is connected to x1 y1. We don't have to check x1 y1 is connected to xy. And then we can connect it to this point. This point, there will be some other m1 value, m2 value, m3 value. But when I connect to this point, it is again m2. So then I will say that okay, with for this point we have 2 value. At this point we have 4 value. And I think you are getting the intuition how we are solving this question. So basically at every point I am trying to connect that point to all other remaining points. When I'm doing that, I am calculating the slope of the line segments that I am getting by connecting those points. After getting those line segments, I will be getting some slope, right? So after getting those slopes, then I will be checking if there is any slope that is equal to the previous ones that I have got. If they are, then I'll be incrementing them, insinuating that I have got a new point. That is the whole crux of this problem. How we can solve this now? Well, obviously time complexity. For every point we'll be connecting other points. So for every ith point, I will be connecting n minus ith points, which means this is nothing but if we have 4 points, then the time will be like 4 is connected to all other 3 points, and 3 is connected to all other 2 points, then 1 and 0. So this is nothing but a n into n, I think minus 1 by 2, or maybe plus 1 by 2. I don't know, but something similar. So this is an order of n square time complexity. So let's solve this question. Okay, so first of all we need n, that is points dot size. Now we need to check if n is equal to 1. If there is only 1 point, then at that line maximum points can be only 1. Now I need double, because slope is a formula that is x. So if I'm connecting this, let's say I'm connecting this like this, x point is connecting to pq point, then the formula of their slope will be q minus y upon p minus x, right? And this is a divide, so there can be integer division could be a distraction, because the fractional part is important, and every slope, every line can be distinguished by their slope if there's a fraction part or not. So slope is equal to, well, initially we don't need to initialize to anything. I will just say slope, and then I need int, and that is my answer, or let's say max points, and that is initialized with 0. Now I can start my loop, right? Now I will be creating an unordered map, and this is double and integer value. So this is basically a map that is containing the information of slope and the maximum points that associate with that slope. That is why we have int, which is the frequency, the number of points. And let it be slope frequency. Now I will start iterating over the remaining points after this ith point. So that is equal to j is equal to I plus 1, j is less than n, j plus plus, and yeah. Now I'll be calculating slope. So slope is equal to get slope of these points, and these points are points of ith value, 0th, that is my x, and points of ith value, that is 1, that is my y. Then you have points of jth value, that is 0, that is my p, and this value. And the last we will have points of jth value of 1, that is my q. So this should give me a slope value, and I'll be creating this function here. So it's a double function, double data type functions, get slope, and it has an x value, it has a y value, it has a p value, and it has a q value. Then I will be returning. So this will be like double y. So q, that is this formula, q minus y, divide by double, and that is this one, p minus x, right? But you know, I'm not sure if C++ will give an error for this one, but still I want to make a check. If p minus x is equal to 0, then obviously I don't want this equation to take place, this division to take place, because this will be like divided by 0. In that case, I'll be returning double max, or you can also return, integer max, but I think double max is more cool. So I'll be returning it, and like I'm not sure if this is double max, dbl max, or what the whole thing was. Okay, double max is double maximum value. Okay, so I'll be returning double max. Now for these points, I will say that slope frequency of this slope is now incremented, and max points is equal to max of max points and slope frequency of this slope. right? So after this point, I will say simply return max points. Now there is this problem that max points will not be, so for example, if I'm concentrating on this point, then it will not be counting itself. So which is why we need to add one to it, and then we will be good to go, I think. Let's try submitting it. Okay. Yeah, it's not performing that bad. I think it's a good solution, good algorithm. Although I'm not aware, I haven't checked the solution section till now. I'm not aware if there are any other methods. Because I've discussed it with my friend, but he was also aware of this method only. So if you have any other methods to this problem, then do let me know in the comment section. And thanks for watching. Have a good day.